Fibonacci, Fibonacci, Fibonacci. What's up, LeetCode? We're going to talk about question 509 Fibonacci numbers today. So, basically, before you learn 509, you need to know something what is called recursion. What is recursion? Basically, every one of you probably will know a magician pulling out a rabbit out of his hat, basically. Out of just thin air, just pulling out a rabbit. But instead of that, what recursion is, basically, all you need to know is a magician has a hat, and he's going to pull out a hat out of his hat. So, boom. We just pulled out a hat here. Out of that hat, that magician is going to pull out another hat from that hat. Boom. And it's going to repeat the cycle. What I'm basically trying to say is the magician is just going to pull out a hat out of a hat. And out of that hat, he's going to call this hat. Let's just call this hat 1, 2. So this 1, that's a horrendous one. 1, 2, 3, 4. He's going to keep pulling out these hats, and he's going to repeat this cycle again and again and again until he meets some kind of stoppage point. For example, he has ran out of space on his show where he can put hats, or maybe he just pulled out another hat in his hat just because he wanted to give out hats to his fans, right? So if he had finished his condition, then that means we're going to end the method. Is that what you're saying? So for example, before we go into 509, let's just talk about this code right here. So public void print hello sysout. I'm just going to call sysout system.out print. Okay, sysout hello print hello. So this is obviously going to run, right? When you call this method. So it's going to run. It's going to run starting from here, right? So, and it's going to print this out. So in our terminal, we're going to have something like hello here, right? And usually this is where the program ends with this. But however, he or she or the coder is going to call print hello again, which is going to print hello again, right? After that, we're going to print hello again, again, and again. So this is going to keep on repeating because print hello is the same function as this. Same function as this. So this and this. So let's just put numbers on it to make it clear. So 1 and 2 print hello are the same thing. So they're basically keep calling hello on itself. Hello, 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 hello. So it's not that hard of a method. However, the problem occurs because our computer doesn't have infinite memory. So we're going to run out of memory. So we're going to have to put some type of condition where this hello stops. Let's just say, let's just delete all of this. Delete all of this. Boop, 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 boop. Boom, boom, boom. Okay. And let's just say we have something like int 5 here. And int n equal to 5, actually. That would be way better. And n equal to 5. And then here we have n minus 1. N equals n minus 1. And we have an if statement. When n equals to 0, we're going to return. So it will keep on printing hello until we meet that condition. So it will do print hello. Let's just say print hello is ph 5, right? And then it will call ph 4. It'll keep on going, boom, 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 until it hits ph 0. And when we do print hello 0, it's going to basically return, right? Because if statement. So recursion is basically calling the method on itself. It's a hard this may confuse you, but let's just say again, you're calling a method on itself. You're calling print hello on itself, like in here, in this method. That's all it is. But however, if you meet a certain condition, you're going to stop print hello. That's all there is to it. So we learned all of this now. We learned what a recursion is. Now let's get to 509 Fibonacci numbers. Don't let these types of questions scare you. If I can solve it, I'm pretty sure everyone watching this could solve it. So 509 Fibonacci numbers, let's do it. So the Fibonacci numbers, commonly denoted Fn, form a sequence called the Fibonacci sequence, such that each number in the sum of the two preceding ones, starting from 0 and 1, that is blah 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 blah, given in, calculate Fn. So in here, we basically know we have to add all these values up, and this is our stop condition, right? When f equals to 0, and when f we're going to call f0, it's going to return 0. f1 is going to return 1. So let's just do a quick example. If we do something like f2, right? For n equal n, since 2 is bigger than 1, basically. f2, this looks like a 3. I'm just going to quickly change it to a 2. Wow. So f2 is going to equal f1 plus f0. That plus and f looks way too similar. Let me quickly fix that. Plus f0. So after you call these two functions through recursion, you would realize we wouldn't come to a stop because f0 equals 0 and f1 equals 1. And 1 is going to be our answer, basically. And we are back. So, Fibonacci numbers. Basically, we always want to put our stop condition in first part of our code. We're using recursion. So, we're going to use recursion here, basically. That's the main idea. So, if what? If n equals 0, we are going to return what? It says f0, 0. So that's going to be our stop condition. Return 0. When f equals to 1, n equals to 1, we're going to return what? 1. And after that, and anything else, right? Anything else, basically. We are going to return fib, the same method, n minus 1 and n minus 2, basically. That's it. That's the end of our function, right? So what this code is going to do, it's going to call itself, basically, every single time. But when we hit f0 or f1, it's going to return these values because this is going to be our end statement. Because if we don't have these two end statements, we're basically going to keep on running the code endlessly, right? Let's run this. And yeah, this is going to be correct. I just, before we finish, I just want you guys to slightly visualize it. Let's go straight into our drawing board again, and let's finish up. Let's just quickly explain what is going on. Okay, so fib4, let's just say we have something like fib4. Fib4, we are going to run this statement, right? Oh, you guys don't see it? We're going to run this statement. Equals fib3 plus fib2. But we don't, now, we go into fib3 and fib2. Let's go into fib3 first. What is fib3 going to do? Fib3 is going to do fib2 plus fib1, right? And fib2 on this side, fib2 is going to be, let's just put it on another line, or we can do something like this. You guys see what is going to fib2 we're going to do. Fib2 is going to do fib1 plus fib0. And what is, so basically what we did here is this just turned into this. And this, fib2, just turned into this, basically. So, in conclusion, what is fib2? Fib2, again, it's going to call fib1 plus fib0, right? And what is fib1 here? We finally meet our condition. What was our condition? When fib1 is hit, we are going to return 1. We have fib1 again here. We're going to return 1. Fib0 here, we're going to return 0. And now we get to the juicy part. What is fib1 going to return? It's going to return 1. What's going to return 0? 0. It's going to be 1 plus 0 plus 1 plus 1. 1 plus 0 plus 1 plus 1 plus 0. It is going to end up 1, 1, 1, 3. So basically, this is how you do it, guys, right? It's going to call on itself endlessly until we meet a certain condition, right? And this is how you do fib numbers. So fib4, going to call fib3 and fib2. What is fib3? Going to turn into fib2 plus fib1. What is fib2 going to turn? Fib1 plus fib0. Fib1 is 1, right? And on this side, what we did our yellow triangle, orange triangle, fib2 turns into fib1 and fib0. So it's going to turn into plus 1 plus 0, basically. And yeah, that's how we do fib numbers. Guys, if you have any questions, please leave a comment. And yeah, this is the end of the video. Thank you so much.